Catlin here, trying to give you guys some help on these practice problems. You get 3 polygons. You're going to have to draw a scaled copy of each using these different scaled factors. You will need a ruler for this, alright? Or some kind of straight edge that can measure how long these sides are. So I'm just going to do some for instances, okay? I don't have a ruler to measure how long this is digitally on my computer screen. So if you measure this on polygon A to say be, I don't know, 3 inches tall, all right? When you scale it by a factor of 2, that means you're going to double it. So when you draw it on somewhere else on this page, on your own paper somewhere, it needs to be twice as big. So when you draw A, that line should be 6 inches tall, right? And if you measure this to be 2 inches, then whenever you draw it over here, it should be twice as long, which is 4 inches. And then the hypotenuse of the diagonal here, in this particular case, I don't know what it might be, but whatever it turns out to be off the top of my head, double that, and that's what you would draw it over here. Okay, so everything in the first polygon A gets doubled. In polygon B, it's going to be a smaller version because you're multiplying it by a factor that's a proper fraction. Okay, see the half? So like if this one is 4, 4, 4, and 4 when you measure it, then when you draw it on your own, you're going to draw one that is 2, 2, 2, and 2. Okay, 2 by 2 by 2 by 2. And you're just going to do your best to draw your scaled copy as best you can. Okay, doesn't have to be perfect, it just needs to be about half the size, right? And then for C here, you're going to use a scale factor of 3/2. This might be tough for some of you. 3/2 is the same as 1.5. Okay, so let's say for instance you measure this and it turns out to be 6 centimeters or something. Then you're going to multiply 6 by 3/2, which is going to give you 18 over 2, which is equal to 9. So that means when you draw the other one, it's going to be slightly bigger. This is going to be 9, and then whatever you measure that by, you're going to multiply it by 3/2 also. And so it's just going to be a slightly larger version of C, but scaled up by that factor that you're given. Okay, so C should be drawn bigger, B will be made a little smaller, A will be made a little bit bigger because it's being doubled. Okay, and then let's finish this off with a little help for problem 2. Quadrilateral A. So you got a quadrilateral. Let's just draw a quadrilateral. Let's just make it a rectangle, okay? Or it's not a rectangle. We'll just draw it as a strange shape. Okay. So it says that 6, 9, 9, and 12. So this looks like the smallest: 6, 9, 9, and 12. Okay. And then quadrilateral B is a scaled copy of quadrilateral A. So you've got a scaled copy over here. The shortest side is 2. So the scaled copy has a short side of 2. So that means over here you've got a scaled version of 2, and then everything else is the same visually, right? But it's been shrunk, right? It's been made smaller. So this has been scaled down. What did they multiply 6 by to get down to a 2? Well, if you were going backwards, you'd say 3. So going smaller, it's the reciprocal of that, which is 1/3. So it's 1/3 the size. So everything gets cut in thirds. 9 cut in thirds is 3. So you got a couple of 3's over here. And a 12 cut into thirds is a 4. So you got this new shape, this quadrilateral B over here, that has all 1/3 of the size of what was there originally. And it wants the perimeter of it. So you just got to add up 3 plus 2 plus 3 plus 4. So 4 plus 3 plus 3 plus 2, 6, 10, 12. Hope this is helpful. You guys, good luck on your homework problems.